So let's do this together now. Okay, so again, we have a new substance. I called it element Y. And again, it turns out that this element radioactively decays by 50% each day. This is actually what half-life is. Well, it's related to half-life, I should say. I'm sorry. I misspoke, my mistake. It's related to half-life. All right. So 50% then, in other words, 50% of the remaining amount of how much is left over is gone each day. So again, it's kind of like with the previous question, right? You know, you have a certain amount, and then after a day, 50% of the amount is gone. So if we have, let's say, 1,000 milligrams, right? That's what we're assuming. How much will be left over after X days? So after 1 day, half of this is gone. So we'll only have 500 milligrams. And then another day after that, and then another day goes by, we'll have 250 milligrams and so on. We can get a formula for it. It's very similar to the previous question, right? You know, the initial amount that goes in front. Since 50% is how much it's breaking down by, that is our decay rate as a percent, excuse me. So as a decimal, we get 0.5. So R is 0.5. So we have 1,000 times 1 minus R, which is 1 minus a half to the X. And so we get this. So we get this. So we get 1,000 times 0.5 raised to the X. So that's our function. Okay, so how much is left after a week? Well, a week is 7 days, right? So after 7 days, we're going to have this amount after a week. It's approximately this amount, you know, rounded to 2 decimal places. Okay, now the next one's a little tricky, the next part. How much will be left after 9 hours? Well, you can't just replace X by 9, right? And why is that? Well, because X is in days, right? Remember, the units here, where is it? Here, X is in days, but if you want to know how much is left after 9 hours, well, you're going to have to express hours in terms of days. You got to make sure the unit is right, and that's what we're doing here. So we're doing a unit conversion. Okay, so we know there are 24 hours in a day, right? Okay, so to do a unit conversion, I'm using a proportion. We have 24 hours is 1 day, so 9 hours is how much of a day, right? So it's just like in chapter 2. We have to set up a proportion. Well, I guess you could do the factor label method. I'm doing the proportion method, right? We have 24 hours is a day equals 9 hours over X days. X is what we want to know, right? X is how many days 9 hours is. So the units cancel, right? Day and days cancel. Remember, even if it's plural or singular, they still cancel. Then we get this. And just like before, we have to cross multiply. So you get 24 times X, or X times 24, same thing, equals 1 times 9. Now, how do you get X? You have to get it all alone, right? You isolate it. So in this case, we divide by 24. Now it looks like a Z, but it's a 2 over here. So we divide like so. So we get X then is 9 over 24, which is 0.3750. Now remember, we're rounding the answer to about 2 decimal places. Now, why did I have 3 here? That's a mistake on my part. So, but again, we're rounding to 2 decimal places at the end. So we do F of this. and we just plug it in. And if you round it, you would get 771.11 milligrams. I did 0.105, but I should have done 0.11, so I'm sorry about that. My mistake. So, all right. Okay. All right. Any questions on this? All right. So the next part is going to be a little bit tricky. So let's go through that. So let's suppose we have an investment, and we make an investment of $9, okay? And somehow whatever we do with it, we find out that it's increasing in value at a rate of 12% every year. So notice though that here, right? Notice that this is actually, this is exponential growth, right? Because it's growing by at a constant percent rate each year. It's growing at a constant percent rate each year. So we do have exponential growth. So if we let X be how many years since the investment, and we're getting a formula for it, this would be our formula, right? We have the initial amount, which is 9. The growth rate is 12%. As a decimal, it's 0.12. So we get this, which is the same as 9 times 1.12 raised to the X. Okay. Now here, what I'm doing is I'm just using some values here. I'm just calculating some values, okay? So for instance, when time is at time 0, the initial amount, we get 9, right? You know, if you plug in X equals 0, you get 9. After a year goes by, right, we're going to have that. What's going to happen is we're going to have 9 times 1.12. You know, you just plug it into the function, and we get this. When another year goes by, okay, right, so we're at X equals 2, we're going to have this amount, 9 times 1.12 squared. Now, of course, if you think about what the exponent means, you know, that means we have 9 times 0.12. We're multiplying this by 1.12 to get this amount. You know, when you square something, that's the same as multiplying it by itself. So that's another way of looking at it. Another year goes by, we have 9 times 0.12 cubed, 1.12 cubed, which means you're taking 9 and multiplying 1.12 with itself 3 times, which is the same as squaring it and then multiplying it by another one, which gives you this. What I'm trying to show you is every year, right, we know that the value of our investment is going to increase by 12%, which amounts to multiplying by 1.12 to get the total amount. Now, why am I saying that? Well, let's consider this example. What if instead the value would increase every 2 years? So we made an investment of $9, okay? $9. And we know it's increasing at a rate of 12%, but this is happening though every 2 years, not every year. Well, here, what if we want to find the value of the investment in X years? So it's just like the previous example. We want to know how much the investment is worth, or how much, you know, how much it's worth after X years. Well, since it's increasing by 12% every 2 years, right? That basically means the value is not going to increase every year. It's going to increase every 2 years. And really, to accommodate that, we have to replace X in our formula by X over 2. right? Remember how I said already, and I tried to show you here, every time it increases in value, right, you multiply by 1.12. That's how much in total is remaining, is in the investment. That's only going to happen every 2 years, though. It's not going to happen every year. So in our formula, we have to replace x by x over 2. And that's what I'm trying to show you here. At time 0, again, we still have 9. It's not going to grow in value until x equals 2. That's when you multiply by 9.112, which is 2 over 2. So we basically have to replace x by x over 2. I'm trying to illustrate through the calculations here, okay, why we do x over 2. You know, like when x is 4, for instance, that's 4 years since the investment, right? Well, it's only going to grow in value twice. And that's why we want a 2 in the exponent, well, 4 over 2. Well, let me just fix the record. Let me just do something with the recording.